I like databases, right? And one of the topics that I like the most about databases is, obviously, performance always triggers me to go deep and into the weeds of any database. And but another topic that I'm really eager to learn more about and always studying, trying to improve, learn new concepts, and come up with state-of-the-art solutions is high availability. And on that topic, I really feel and I'm really interested not only in the Oracle database, but in other databases like Cassandra, other databases like Cassandra, Yugabyte, Google Cloud Spanner is one of my favorites as well, because all of these databases, they implement something that it's really hard to achieve in regards to relational database in this distributed and global architecture. So Cassandra is not relational, so that goes off the topic here. But Yugabyte and Google Cloud Spanner, they are really interesting in this distributed SQL model that they implement, where they guarantee pretty much a high consistency. And when we discuss about distributed SQL databases, it's really hard to implement this consistency at scale, I would say, and in a distributed fashion, because it is hard for you to write data in some other place of the world, and that same data be available and consistent with the data that you have, let's say, in your local data set or partition, I would say. So it is a really interesting concept, and I think December, in the AWS reInvent, they released the AWS DSQL, which stands for Distributed SQL, which is also another flavor of a distributed relational database, implementing similar concepts of the Google Cloud Spanner that was actually released back in, I think it was February 2017, when I was living in São Paulo, here in Brazil. I went to they had a Google Cloud Summit in São Paulo, and I attended the session when they released the Cloud Spanner back then, and I fell in love immediately because Google Cloud Spanner was impressive, what they could implement. And I was back then I was really skeptical because how was it possible they could achieve pretty much the asset concepts in a distributed fashion. That's really amazing what they were capable of doing. So today I would like to explore more and explain a little bit more about high availability concepts and the CAP theorem. I don't know if you are aware of it. So I would like to explain more a bit about these topics, and we will understand what Yugabyte, Aurora, or AWS DSQL, and Cloud Spanner implement, why it's difficult to achieve that, and why there is some sort of skepticism around it that regular database professionals don't understand. So let's go into it. So when we talk about high availability in general, we have to go into the details of what it is, right? So a system or a database that is highly available, it is highly available. It means that it is available most of the time. And but how much is highly available? How much is it? How much that means? So we have the nines of high availability concept. So when you see that somewhere in the documentation that a system or a database has 5 nines of availability, that means actually that's 99.999% of availability in a year or in a defined period of time, right? And how much that means, right? So how much is 5 nines of availability? How much is 7 nines of availability? How much is 4 nines? How much is 3 nines, right? So let's discuss that to understand. And but first, I wanted to touch base on the high availability topic itself. So for a system to be highly available, it requires all the components of a system to be redundant and resilient to any failure. So if you have a database that's running in a single server that has only one disk controller, one CPU socket, or one power supply unit, if one of these components fail, your database will go down, right? Because the server will go down. So usually we build servers or we build databases and systems on servers that have redundant components. So usually we will have 2 sockets for CPUs, a bunch of banks for memory, many disks with at least 2 controllers, or even many or multiple storage servers where you implement the RAID concept, or even if you don't have RAID, let's say like Cassandra, you have distributed data across many servers and a replication factor to be defined. Sorry, I had a glitch here on my audio, so I ended up recording all the content yesterday, but everything from this part now on had no audio on the video, so I'm gonna re-record this. So as I was saying, in Cassandra we have a replication factor to take care of the redundant storage, and we don't implement using RAID or any other protection technology on the disk layer. And on the same topic, with Oracle we have the ASM redundancy configured, and that's also used to implement data protection in the storage layer. So usually we don't have RAID on the ASM disks when usually when you are when you are on Exadata, you don't have RAID on the disks, but you have double or triple mirroring by configuring the ASM disk groups with normal redundancy, which is double mirroring, and high redundancy, which is triple mirroring. So yeah, that's usually how we build database systems on redundant servers. If you go to wikipedia.org and search for high availability, on that page on Wikipedia you have a chart where you have the high availability nines there. So it starts on the 90% availability. And what does that mean when we talk about availability and you have 90% of availability, right? So you have 36 days and a half of downtime per year if your system is only 90% of the time available, right? So if we go to the 99% of availability, that means that you have a downtime of 3.6 days in a year, or pretty much 22 hours in a quarter, 7 hours per month of downtime, or 1.6 hours per week of downtime, or 14 minutes per day, right? If you go to 3 nines of availability, so 3 nines of availability, it is 99.9% of availability. That's 8.7 hours in the whole year, 2.19 hours in a quarter, and 43 minutes for almost 44 minutes per month. And if you have 4 nines of availability, which is 99.99%, then you reach the 52-minute mark of downtime in a year, or if you consider per month, that's 4.3 minutes of downtime in a month. And a lot of systems and cloud providers, database providers, they will say they have 5 nines of availability. How much is that? That's 5 minutes of downtime in the whole year. It is really hard to achieve that, and that is for both planned and unplanned maintenance or outages, right? So this is really hard to achieve. And if we go even further, 7 nines of availability, right? That's 99.99999% of availability. That's 3 seconds of downtime in the whole year. That's huge. I mean, really hard to achieve that. Really hard to achieve. So now we will go deeper into the CAP theorem and understand what the CAP theorem is.